Hi, this is Ivan and welcome to the channel. Today I'd like to have a discussion regarding altimeter errors. There are a handful of altimeter error questions on the FAA Knowledge Test, and I find that exam applicants often have multiple questions regarding these type of questions because they can often be confusing. What I'd like to do is demonstrate a technique to help approach these questions in such a way that the student will be able to get these questions right pretty much every time. What we'll then do is we'll take that technique and we'll do some practice questions and see how it works. Afterwards, what I would like to do is have a more in-depth discussion regarding the science and mechanism behind altimeter errors. Now, if you find that discussion more confusing than helpful, my recommendation would be to stop and then go back and just focus on the first part of this video. And then once you get your head around it or more comfortable with the material, then proceed with the discussion of the science and the physics. I do believe that having a greater understanding of the science will help with retention of the material and application of the material. So let's get started. Okay, so before we demonstrate the technique, what I'd like to do is review some basic definitions. For some of you, this will be the first time seeing these definitions. For others, this will be reviewed, but they are important to the topic of altimeter errors. Indicated altitude is simply the altitude reading on an altimeter. It doesn't imply accuracy. It's just whatever the altimeter is indicating. True altitude is the vertical distance above mean sea level. Think of true altitude as where the plane actually is above mean sea level. Think of indicated altitude as where the plane thinks it is above mean sea level. Absolute altitude is the vertical distance above ground level, and when having a discussion about altimeter errors, you certainly want to know where you are in relation to the ground. Pressure altitude is the indicated altitude when the altimeter is set to standard pressure of 29.92 or 1013.2 millibars. Doesn't matter if you're at field elevation or higher. Once you set that altimeter to 29.92, you're now getting a pressure altitude reading from your altimeter. Density altitude is that pressure altitude, but it's corrected for non-standard temperature, and we'll have a discussion about that in just a second. International standard atmosphere, this is standard conditions, and this is basically when the pressure at sea level is 29.92 and 59 degrees Fahrenheit, again at sea level, or 1013.2 millibars and 15 degrees Celsius at sea level. And this is considered standard conditions, doesn't often exist, but these are the standard conditions to which other comparisons can be made. Now, for the FAA test, please be mindful that they will often mix their standards of measurement, meaning that you may have 29.92 and 15 degrees Celsius in the question, so be mindful of that. Here's an important concept, and that is altimeters are calibrated for standard temperature. Temperature does affect pressure. Pressure will affect the altimeter reading. So it is important to know that there's no setting on a mechanical altimeter to adjust for that. So that's very important to know. And we'll discuss that later in the more in-depth portion of the thing. Different ways to ask the same question. So on the FAA exam, what they'll do is they'll take this concept of altimeter errors and they'll approach it in different ways. They'll word the question differently, and sometimes it can be confusing. My best advice is we'll demonstrate this technique here in just a bit, but take this technique, apply it, go slow. There really is no rush. You have plenty of time to answer the questions on the exam. Let's look at these first two. Is the plane higher or lower than altimeter reading, or is the altimeter reading higher or lower than the plane? So think about this. Is A higher than B, or is B lower than A? I just described the same situation, but I use different terminology, and so that's how it can get very confusing. So watch what you're doing and go slow. Let's look at these next two. Under what conditions will true altitude be higher or lower than indicated altitude? Under what conditions will indicated altitude be higher or lower than true altitude? So what they're going to do here is they're going to give you which is higher, true or indicated, but then they're going to ask you to describe the conditions that would cause that, which is different from the first two questions where they're going to give you the conditions and have you determine what the relation between true and indicated altitude is. And all of these questions, when it regards altimeter error, they are pretty much all related to pressure or temperature. So let's move on and we will discuss the technique to approach these questions. So now what I'd like to do is demonstrate this technique to approach these questions. So what I physically do is I hold my hands up just like this. The hand with the watch represents true altitude or density altitude. The hand without the watch represents indicated altitude and sometimes pressure altitude. And so basically they're in relation to each other. Right now they're equal, but in some situations true will be higher than indicated, indicated lower than true, or true is lower than indicated, or indicated is higher than true. What makes the true altitude hand move? And that's going to be pressure or temperature. I don't generally move the indicated altitude hand. I just leave it static. It's just easier for me. You can do how you like. So what makes the true altitude hand or density altitude hand move? That's going to be pressure or temperature. So going from a lower pressure to a higher pressure, a cooler temperature to a warmer temperature will make the hand go up. The true altitude hand go up. Going from a warmer to a cooler temperature, or a higher pressure to a lower pressure. And that's what's going to change the hands. And what I do is I move them around as I read the question, and then I'm going to end up with one hand having a relationship to the other. And that's going to help me answer these questions. Let's try to answer some sample questions and see how this works. Okay, let's look at this first question. Which condition would cause the altimeter to indicate a lower altitude than true altitude? So let's set this up. Which condition would cause the altimeter to indicate a lower altitude than true altitude? So in this case, something caused true altitude to go up, and now indicated altitude is lower than true altitude. So let's look at the responses and see which one fits. Air temperature warmer than standard. So we said warmer will cause the plane hand, the true altitude, to go up. Air temperature warmer than standard. And in this case, indicated altitude is lower than true. So A is looking pretty good, but let's look at B and C. Atmospheric pressure lower than standard. So bringing the pressure down. But in this case, indicated altitude is higher than true. So that doesn't fit. Response C. Air temperature lower than standard. Remember, temperature lower brings the true altitude hand down with the watch. And that would lead to indicated being higher than true altitude. And again, that is not what the question is asking. A is correct. Air temperature warmer than standard causes indicated altitude to be lower than true altitude. From a strictly test-taking strategy standpoint, B and C are almost the same response. Atmospheric pressure lower, air temperature lower, both end up with indicated altitude higher than true altitude. So you could almost eliminate those two responses just from that information alone. If a flight is made from an area of high pressure into an area of low pressure without the altimeter setting being adjusted, the altimeter will indicate. So let's set this up again. If a flight is made from high pressure to low without the altimeter being adjusted, the altimeter will indicate, well, here it's indicating higher than true. So let's see which one of these responses match that. A, the actual altitude above sea level. No, that would look like this. Indicated would be equal to true. B, lower than actual altitude above sea level. So that would look like this. And that's not what the question is saying. High pressure to low. Let's look at C. Higher than actual altitude. So we went from high pressure to low, and here we have the indicated altitude, or the altimeter is reading higher than the actual sea level, altitude above sea level. So C is correct. This is the proverbial from high to low. Look out below, because my indicated altitude is higher than my true altitude. I'm closer to the ground than I think I am. Let's look at the next question. Under what condition will true altitude be lower than indicated altitude? Under what condition will true altitude be lower? So true altitude lower than indicated altitude. So let's look at the responses. When density altitude is higher, so here this hand would move up, and now indicated is lower than true. So A is not correct. In colder than standard air temperature. So let's look at that. We said cold brings down the true altitude hand, the one with the watch. So in colder than standard air temperature, and yes, indicated is now higher than true, or rather true is lower than indicated. Let's check out C. In warmer than standard air temperature. So warmer brings the hand up, and now we have true altitude is higher than indicated. So that's not correct. So the correct response would be B. Under what condition will true altitude be lower than indicated altitude? In colder, that brings the true altitude hand down, the hand with the watch. In colder than standard. So here we have the true altitude is lower than the indicated altitude. All right, let's look at the next one. If a flight is made from an area of low pressure into an area of high pressure without the altimeter setting being adjusted, the altimeter will indicate. Let's take a look. So the flight is made from low to high. We didn't change the altimeter. The true altitude hand came up. The altimeter will indicate. Well, right now it's indicating lower than true. Let's see which one fits. A, higher than the actual altitude. No. No, right now it's lower than the actual altitude. B, the actual altitude above sea level. No, that would look like this. C, lower than the actual altitude above sea level. And C is the correct response. If a flight is made from low pressure to high pressure without the altimeter setting being adjusted, the altimeter will indicate, this is the altimeter, will indicate lower than the true or actual altitude above sea level. Hopefully this is starting to make sense. This one looks a little bit different. If the outside air temperature at a given altitude is warmer than standard, the density altitude is. So let's set this up, but it still works. If the outside air temperature at a given altitude is warmer, we said warmer goes up, cooler goes down, but warmer goes up. The density altitude is equal to pressure altitude. Well, no, that would look like this. B, higher than pressure altitude. Well, we said is warmer. And right now, yes, higher than pressure altitude. So B is looking pretty good. C, lower than pressure altitude. Well, no, we said that the outside air temperature is warmer. And so the correct response is B. If the outside air temperature at a given altitude is warmer than standard, the density altitude is higher than the pressure altitude. Okay, so this question is a little bit different too. How do variations in temperature affect the altimeter? So what we're going to do is we're going to read through the responses and see which response is true all the way through. Let's take a look. A, pressure levels are raised on warm days. So pressure levels raised on warm days, warm goes up. That is correct. And the indicated altitude is lower than true altitude. And that is correct. That looks good. But let's go through the other ones just to make sure. Lower temperatures lower the pressure levels, and the indicated altitude is lower than true. Right now, indicated is higher than true. So just based on that alone, we know that B is not the correct response. Lower temperatures and the indicated altitude is lower than true, and that is not the case for what the question is asking. C, higher temperatures expand the pressure levels. Higher temperatures, the true altitude hand goes up, and the indicated altitude indicated is higher than true. Well, it's not in this setup. It's lower. So C is not looking right. The answer is A. Pressure levels are raised on warm days, correct, and the indicated altitude is lower than true altitude. That is also correct. So the response is A. Okay, under what condition is indicated altitude the same as true altitude? So this one is a little bit different in that you're not going to necessarily do the setup, but you're going to have to go through and see which one would cause this situation to occur. Indicated to be the same as true. A, if the altimeter has no mechanical error. Well, that's not right because an altimeter can be in perfect condition But if it's not adjusted appropriately in terms of the barometric pressure, if you're not setting your pressure correctly, then it could be reading improperly, and so indicated may not be the same as true. So A does not seem correct. B, when at 18,000 feet MSL and the altimeter is set to 29.92, well, that's describing flight levels, and there's no implication that flight levels are going to work out in such a way that indicated altitude is the same as true altitude. C, when at sea level under standard conditions, yes. When at sea level under standard conditions, indicated altitude will be the same as true altitude, so it looks like C is the correct response to the question. Now I just included this one here. It's not necessarily an altimeter error, but just to kind of, it's a question that you will encounter, and so I just wanted to kind of give you a little bit of a heads up. If a pilot changes the altimeter setting from 30.11 to 29.96, what is the approximate change in indication? So what you need to know here is that the altimeter, when you adjust the setting, it will go, if you go from a lower pressure to a higher pressure, the indicated altitude will increase. If you decrease the pressure setting, the altimeter indication will decrease. And what you're going to do is you're going to subtract 29.96 from 30.11, and you're going to get 0.15. And then remembering that 1 inch basically of pressure in terms of millimeters mercury ends up being about 1,000 feet. What you're going to do is you're going to multiply that number by 100, and you're going to get the altimeter will indicate 150 feet lower. So you turned it from 30.11 down to 29.96. The indicated altitude would go down, and it would indicate about 150 feet lower. So this was just included to demonstrate that if you do have an altimeter that you didn't adjust, if we didn't make that adjustment, then just from that small amount, that indicated would be off by 150 feet from true. So that's just something to be aware of. So hopefully we were able to successfully demonstrate that applying this technique to these questions will, by and large, help you get them correct pretty much every time. Now, what I would like to do is have a discussion about the physics and science, and we'll kind of go more into the detail about how this actually affects altimeter errors, and we'll kind of go to that section next. What I'd like to do now is discuss the science behind altimeter errors. We'll discuss how pressure can affect the altimeter and then how temperature can affect the altimeter in terms of errors. But first, what I'd like to do is briefly go over the altimeter itself. This is a diagram taken from the Pilot's Handbook of Aeronautical Knowledge, published by the FAA. And it's just a simple cross-section of a mechanical altimeter. And if you think about it, an altimeter is basically an analog computer, and it really only has two variables. The first thing would be, of course, the pressure that's present at the static port. That is one variable that can change. And then also the adjustment to the barometric scale, that's another variable. So really, other than that, you take those two inputs, and then based off of how the device is calibrated, it will give an indicated altitude. What I think is important to note, there's two things I'd like to point out. One is that this altimeter is calibrated for one temperature only, and that's 59 degrees Fahrenheit or 15 degrees Celsius, the standard temperature. There's no setting or adjustment that will change that on the altimeter. The second thing I'd like to point out is that the altimeter is not aware of the column of air below. Let's say this is a column of air. The altimeter has no idea what that column of air is doing, what the density of it is. It is only sensing the column of air above it, and that's important. So bottom line, the altimeter is not a thermometer, and it does not know what's going on below that. So let's talk about how barometric pressure can affect the altimeter and what situations can occur to cause an altimeter error. So the first thing I'm going to do is draw a couple of lines here. And we'll say this line and then this line. And what each of these represent or a certain altitude of true altitude. So let's say this bottom line represents 4,000 feet MSL, true altitude, and this top line represents 5,000 feet MSL, true altitude. And then what I want to say is, let's represent the plane by just simply drawing a circle, which could represent the static port. So I'm just going to do that. And let's say that in this particular column of air, the barometric pressure at sea level is 30. And let's also stipulate that the pilot has appropriately set their altimeter to 30, meaning that the indicated altitude equals 5,000 feet above sea level, which also happens to be the true altitude. So that's what we're looking for. But let's say as this plane flies from left to right, it moves to an area of lower pressure, and we'll say that pressure is 29. What's going to happen then if the pilot does not adjust the barometric setting on the altimeter from 30 to 29? What will happen is the pilot or the autopilot will follow the pressure gradient to get to left to right, and it will basically try to keep the altitude at 5,000 feet. And what it's looking for is a certain pressure to cause a readout of 5,000 feet. And as the pilot or autopilot, you're just looking at the altimeter, you're maintaining a readout, an indicated altitude of 5,000 feet, but actually you're descending. Let's add another point here. Let's call this just like a midpoint. And we'll say this is a pressure gradient. And the pressure here is 29.5. And then here's our static port again. In all three cases, if the pilot doesn't change the pressure, the indicated altitude will equal 5,000 feet. Okay, this is the proverbial, again, from high to low, look out below. So here the indicated altitude is 5,000 feet, but the actual altitude is 4,000 feet. And it's never optimal to be that much closer to the ground without realizing it. So how does this happen? What is the cause of this, and what can we do to fix it? So what I'm going to do is I'm going to demonstrate how this works. Let me add some columns of air here, and we'll kind of see what's going on. So what I'm going to do is I'm going to add this column of air, and I'm going to go up to right about here. We'll call this column of air. And then here's another column of air that these planes are occupying at any given point in their flight path. So how does the altimeter then know where it is? Well, certainly it's been calibrated. And let's say, and we discussed that the altimeter is basically an analog computer, that when the altimeter senses a certain amount of weight or pressure above it, doesn't know what's below it, but what's going on above it, and the altimeter has been dialed into 30, let's say it requires X amount of pressure, and let's say X is equal to 10 particles of air. Certainly that's not the case, but we're just for demonstration's sake. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this altimeter, when set to 30, requires 10 particles of air. Now, what we also know is as we go from a higher pressure to lower pressure, that air column, the particles will be less dense, meaning that there will be more space between the particles, and that the same amount of particles will occupy a larger space. So that's what's happening as we move from left to right. So here, now it's still looking for, basically along this flight path here, it is looking for 10 particles of air above it to maintain a readout of 5,000. That is assuming we have not changed the barometer reading of, or setting rather, of 30. So over here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here it still needs that 10 particles of air to read 5,000 feet. And because the pressure is lower, those air particles are going to be farther apart, meaning that if the plane was actually, say, somewhere around where the blue line is, it would only have 6 particles of air above it, and it would indicate a higher altitude. But because we're trying to maintain a flight path of 5,000 feet, that altimeter, that analog computer, is seeking out 10 particles of air or X amount of pressure or weight above it. And we can continue this on all the way over to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still looking for that 10 particles of air or X amount above it. Doesn't care what's going on below it, above it. And if we don't change our barometer from 30 to 29.5 to 29, the indicated altitude is going to maintain 5,000 feet, yet we will be descending from high to low, look out below. And this is how these altimeter errors can occur. The altimeter is simply an analog computer with 2 variables, the amount of pressure above it and whatever we set our barometer to. And based on those 2 numbers, it's going to calculate a given indicated altitude. In this case, 5,000 feet. So how could this be avoided? Just by maintaining the correct pressure. So also visualize here, what are we going to do if we were to correct the barometer here? Remember from one of the sample questions, if we turn the pressure window down, the indicated altitude will decrease. So if I change the reading from 30 to 29, that indicated altitude is going to decrease by 1,000, which would then make it accurate with the 4,000 feet true altitude. So hopefully this demonstrates how pressure can affect the altimeter and how altimeter errors can occur as they relate to keeping the barometer set appropriately. Now I would like to discuss how temperature can affect the altimeter in such a way that it causes altimeter errors. Temperature as it relates to altimeter errors is a topic where students and even some pilots will often get confused. And I think one of the reasons for this is because it's just not very well explained in the common literature that's out there. So what I want to do today is try to explain this in such a way that maybe we can kind of figure out what's going on. So first thing I'm going to do for my drawing here is I'm going to draw my base. And this base, this green line, represents 0 feet MSL. And so let's add some columns of air. This will be the middle column. And then we'll have a slightly taller column and a slightly shorter column. And the big difference between these 3 columns is going to be temperature. Let's say this middle column is, let's say it is 60 degrees Fahrenheit. So 60 degrees. And let's say this one here is 40 degrees Fahrenheit. And let's say this one is 80 degrees Fahrenheit. And one of the things that we know about air is when it's warmed up, it expands. And when it's cooled down, it is contracted or it contracts. So how then, why is this confusing? And I think I know also why this is confusing. I think what happens is, let's refer to this previous diagram. Students are trying to apply this diagram to the temperature diagram. And the reason being is I think we all have anecdotally, or we've all experienced and had this anecdotal knowledge where we have trended that on cooler days, the barometer is higher than on warmer days. And we will often see as the seasons change that the barometer reading may trend in a given direction, depending on if it's going from warm to cold or cold to warm. And I think what we're doing is we're trying to apply that to the temperature questions on the FAA exam, and it doesn't work. In fact, it gives you the opposite answer. And let's demonstrate that really quickly here. So what I'm going to do is, let's say on this this area where the temperature, where the pressure is 30, let's say the temperature is 40 degrees. And let's say over here where the pressure is 29, let's say that the pressure, or the temperature rather, is 80 degrees. And so if we try to answer the question, if we go from a cooler day to a warmer day, will indicated be higher or lower than true altitude? If we try to apply this type of information, this scenario that we're looking at right now, to the actual question, we're going to get it wrong. And let me show you. So what I'm going to do is let's try this out. So I've got my technique that I've demonstrated earlier. And the question is, if we're going from a cooler day to a warmer day, so true altitude should go up compared to indicated altitude. So here I have true altitude. True altitude is higher than indicated altitude because we went from a cooler to a warmer. So true, higher than indicated. But look, what we actually have is indicated higher than true. And so that's the opposite. So that is a problem, and I think that is why we get it wrong. So what is happening then? What can we do to explain this? And let me show you. What I think is being left out, or at least is not abundantly clear, is that yes, the temperature is changing as we go from left to right, but what is not changing? What's not changing is the barometer. Let's say that this is a pressure of 30. Well, this is also a pressure of 30, and this is a pressure of 30. Contrasted with over here, the pressure is changing from one column to the next, where the temperature has made the barometer change, but in this scenario, the barometer has stayed the same, but the temperature has changed. And what is happening is these columns of air are physically shrinking from left to right. So this top green line here represents the top of the column. There's no atmosphere past this line. This is literally the top of the air column, all the way from the surface of the earth, 0 feet mean sea level, all the way to the top of the atmosphere, and that is the end of it. And so what is happening as we go from left to right, these columns of air are physically shrinking. Well, what does that mean? How does that affect us? What it means is the lapse rate is also changing. So the lapse rate is how much of a change there will occur, say in temperature, over a given amount of feet, or how much change in pressure over a given amount of feet. And so let's take a look at this. Let's bring back the green line here, and let me demonstrate this. So what I'm going to try to do as best I can, I'm going to try to divide this in half, and then do that again, and again, and again. What I'm doing here, this would kind of represent pressure levels or lapse rate, and I'm going to try to get this close, but I'm not an artist, and this is not the scale. So, but you can already kind of see what's happening as we go from left to right. If you pick a certain box, that box in the column next to it will probably be a little bit lower if you're going from left to right. So that is what is changing, and that is the part that I think is just not abundantly clear. The pressure is the same, the temperature is changing, and the column of air is actually shrinking if we go from warmer to colder. And let's further illustrate this. Let's say that you're flying at 5,000 feet, and your barometer is appropriately set. And let's just say, for the sake of demonstration, that 5,000 feet occurs in terms of pressure 1, 2, 3, 4, 5, 6, 7. So let's say your plane is, let's pick a different color here, that the plane is here. That in this 7th pressure level is where the barometer, or the altimeter rather, will indicate 5,000 feet. Well, look what happens. If we go to the column next to it, the 7th box up is here and here. And what we can definitely see is a trend. As we go from left to right, we can see that the plane is in fact descending in altitude. The true altitude is decreasing, but the indicated altitude is going to be the same. Why? Because the pressure level is the pressure for the barometer on the altimeter is appropriately set, and that pressure level is expanded in the left column or the warmer column. And so this is where it would occur for the altimeter to indicate 5,000. And so this is why on the FAA question, when they have a change in temperature, why they get the answer they do is because the lapse rate is changing, the temperature is changing, but the pressure is not changing. So hopefully that will help a little bit. Let's take a look at another drawing here. This is actually the drawing from a graphic from the Pilot Handbook of Aeronautical Knowledge published by the FAA. And this is a better drawing than what I just drew. But what I think they're leaving out again is that what is the same from left to right is, let's just say that the pressure is the same. It has to be for this to work. If the pressure changes, then we're talking about a pressure change, and that is more of what's going on over here. But if it's just the temperature changing, at least as far as the FAA questions go, what is understood but not, I think, appropriately distributed in terms of knowledge is that the pressure is not changing as we go from left to right. And you can see that, again, the plane is trending this way. It's descending in altitude. The true altitude is changing, but the altimeter is not going to change because there's no reason for it to. It's appropriately set, and it's sensing for, it's looking for that pressure above it, and it's going to occur at a lower and lower place because here to the left, the warm air is expanded, and here to the right, it's contracted, but it's the same pressure at sea level. It just means this column of air is, in fact, shrinking. So hopefully you found this information helpful. You may have to watch some of these sections more than one time, and certainly you may have questions. If you do, please put them in the comments below, and I'll do my very best to either answer them or get you heading in the right direction. In any case, good luck on your studies and have a great day.